Hey guys, I figured I'd do a little bit of sort of fossil show and tell, since some of you guys are kind of bringing this up and posting about things about casts and permineralization and that kind of stuff. So here I have two fun fossils, and I apologize for the Dave Matthews in the background. My fiance is currently running around cleaning the house, and that's what she cleans the house to. Yeah, so these two fossils, and it's probably not too hard to guess what this one is here on the left. Can you tell what that is? This is from near Petrified Forest in Arizona. Not actually within Petrified Forest, because that would be illegal if I had this. But it's nearby, outside the park boundaries that I found this. But it's a piece of petrified wood. And if you ever get the chance, so by the way, if you guys ever drive down I-40 out towards the Grand Canyon, right off of the highway, I-40, you can hit up something in Meteor Crater, which is in eastern Arizona. It's a huge crater that we'll look at later on in class, probably. And there's also, where else do you go through? There's the volcanic fields in New Mexico that you'll drive through. And there's Petrified Forest, which is, and all these places are right along the interstate on the way out to the Grand Canyon. It makes for a really, really simple, really awesome geology sort of field trip. So if you're ever going out that way, kind of Google these things. They're really unique and worth seeing, especially Petrified Forest. Anyway, so what is the process of permineralization? And really, you know, there's kind of a definition for fossils that we talk about, and, you know, it's like evidence of past life. Well, I mentioned in one of the other comments about, you know, I once saw a busted up reef that had kind of solidified together in the Bahamas, and it had only been there for a few decades. And in fact, within that reef, there was actually a glass bottle that was in it. So it basically looked like fossiliferous limestone with a glass bottle in it. Well, technically, the glass, you could say the glass bottle is even a fossil itself because it's evidence of past life. It's evidence of people being in that area or somewhere and chucking a bottle into the ocean, and it ends up in the reef and gets solidified. Technically a fossil, just sort of by that definition, but I think a lot of people actually think of a fossil as something that kind of goes through permineralization, or it actually gets altered to where the piece of the organism that once existed has now been changed and is now essentially a rock. So this is a really good example of that. This is a dinosaur bone, so it's the end of a leg bone. So here you're kind of seeing, so imagine like the end of your femur, right? The end of your thigh. And that's kind of like the end of this here. That's just that articulating joint, like right here. So there'd be another bone down here that would articulate against this. And then it would get kind of longer and stringier up here, or thinner. But if we look closely at this, you can really see the kind of porous texture that you see in bone normally. You see that? Let me get the special magnifying glass here. Maybe this will help. So you can kind of see that kind of spongy porous texture, which is really, you know, what you look for if you ever think you have like a dinosaur bone or a fossil bone. And you can kind of see it here on the end too. But what's neat about this fossil in particular is you kind of see that spongy feature right here. See those holes? But as I shift down here, you don't see that anymore. And down here, what you're seeing is you're actually seeing crystals of quartz that have filled in that little porous part of the bone. And you see it all over this fossil if you look closely. And it doesn't always have to be quartz that does this. A lot of times it'll actually be calcite. In fact, this looks a little wet because I wanted to double check and actually put some acid on it. It did not fizz. But you can see all these kind of quartz crystals in here. So that's really that permineralization. So I put a bone in the ground. Groundwater is moving through the ground. It's saturated in silica because there's probably sandstones nearby. And that will end up precipitating out over long periods of time, precipitating out little quartz crystals within this bone. And the bone itself gets completely replaced by silica to where it's a nice, you know, solid piece of essentially quartz now. I mean, I could scratch glass with this thing. But that's kind of that permineralization. The same sort of thing happens with petrified wood. So if we look closely at this piece of petrified wood, if I asked you what rock this was, you'd say, oh, it's a fossil. Yeah, but what rock is it? It's actually made out of a rock. Well, where's the piece? There it is. This rock, this fossil, is actually made out of this now. It's chert. So it's microcrystalline quartz. That quartz, just like this dinosaur fossil here, has come in there and replaced the wood to where it's now just a piece of chert. And so this one is actually a bunch of small crystals of quartz, but this is like microcrystalline quartz. Right, so basically the same thing, just tiny, 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 tiny pieces. So anyway, so there's a couple of fossils I just kind of wanted to share with you guys that are kind of fun. I forget where I got this dinosaur bone from. I don't think I actually dug this up. I think I found it in a rock shop where somebody thought it was, somebody was selling pieces of petrified wood for like $5 a pound or something, and I realized that's actually a dinosaur bone, and I snagged it for like $8. I do not condone selling dinosaur fossils, but sometimes I will buy them to sort of save them and use them like this to show you guys. Kind of see that spongy texture. Have any other fossils laying around here? What other fossils do I have laying around here? We've got a bunch of fun show and tell things. This is a replica of a fossil. Some of you probably know what this is. It's a very famous fossil. This is a replica of a Megalodon tooth, which, imagine a 50-foot long great white shark. So a school bus-sized great white shark. And these are fun to talk about, one, because they're exciting. Two, they didn't actually go extinct all that long ago. This dinosaur, whatever it was, is probably from the Jurassic, but certainly was extinct by 65 million years ago. But Megalodons were hanging around to about 2 million years ago, and you look at a tooth like this, and you wonder, what was it eating? You don't get a tooth like this for eating, shellfish or small things or eating like a whale does. This is actually for eating whales. So those Megalodons were almost certainly tracking and eating the big baleen whales. Why they died out, I'm not sure. I need to review that. I think there's a number of good arguments. I think we were heading into the recent ice ages. It could have also been that the whales, we know a lot of the large baleen whales migrate heavily, and maybe the Megalodons couldn't keep up with that. But yeah, so that's a replica. What else do I have? I just happen to have some of my fossils sitting here. Oh, there's a fun one. This is an Ammonite fossil. Northwest Arkansas is actually famous for relatives of this fossil, where they were other cephalopods, but with, what are they called? Not belemnites, nautiloids, where they, instead of having a coiled shell like this, they're actually straight. And they would get up to, I think the largest that's been found so far is a 12-foot one. So that's kind of what we're famous here for, fossil-wise, in Northwest Arkansas. And they've been found in the ditch over by I-49 and MLK. So next time you go through that intersection, know that they've found giant nautiloid fossils in the shale there. But here you can see the different chambers that this animal would use, and it would kind of use it as, well, I don't want to say that entirely, but where these chambers meet on the edge of the shell, you get these sutures on the outside, and the more complex these sutures, the older, or I should say younger in age, that these things existed. So this was probably from the Cretaceous, because these are really intricate sutures. And if you find ones where the sutures are just rather simple wavy lines, that probably means they were much older in the Triassic or Jurassic. But you can see that this has gone through permineralization, and the interior here has crystallized into probably, I always assumed it was calcite. I'm not really sure. Let's try and ruin it with some acid. Oh yeah, it's calcite. So unlike the dinosaur bone and this other thing, which are, or the petrified wood, which are quartz now, which are SiO2, this ammonite is calcium carbonate. So there you go. What else do I have? Here's another bone. This one's much older. This is Triassic, but you can kind of see the minerals in there. Little quartz crystals again, similar to the dinosaur bone. I don't actually know what this was from. It's not... It's just too small of a bone, and there's not many distinguishing characteristics. I just know it's a bone that came out of a Triassic formation, so 200 million years ago or so. And what else? I just kind of randomly had this pouch sitting here. This is probably a Mosasaurus Tooth, although it was advertised as a Spinosaurus Tooth, which is probably not the case, but you can see the end here is kind of broken off. But some carnivorous, either aquatic reptile or possibly a carnivorous dinosaur, but very conical sort of tooth used for puncturing, not necessarily serrated like a steak knife, like our Carcharodon here, or our Megalodon here. So yeah, there's just kind of a couple of fun fossils that I had lying around. I just wanted to show you guys, and that's all. Cheers.